A liquid is heated and allowed to cool. The temperature of the liquid at T degrees C after time T minutes, that's capital T for temperature, small t for time, is given by 100 minus 5t minus 0.5t squared for t being between 0 and 10. Calculate the rate at which the temperature is changing in degrees C minutes after 1 minute, 4 minutes and 8 minutes. So if we've got t is 100 minus 5t minus 0.5t squared, the rate of change of temperature is given by dt by dt. Seems a bit strange, but the temperature divided by d the time. So you have to differentiate this function here. Up to now we've been differentiating things like y is equal to 100 minus 5x. We just changed the variables, and this gives me what's known as a rate of change of temperature with time. So if t is equal to kt to the n, then dt by dt is going to be, you bring down the n in front, write down k. So bring down the n in front, write down kt, and then reduce the power of t by 1. So it becomes n minus 1. So now we apply that to each of these things here. So we get dt by dt is equal to, now when you differentiate 100, it's a constant. So you differentiate constant, you get nothing. So you get 0 for that. When you differentiate minus 5t, you just get minus 5. When you differentiate this, you're going to bring down minus 2 times 0.5 times t. And that gives me minus 5. Minus 2 times 0.5 is t, minus 1t. We don't write the 1 in. Now, what we do is when t is equal to 1, we now substitute in. So when t is equal to 1 minute, the rate of change of temperature with time is going to be minus 5 minus 1, which is minus 6 degrees C per minute. When t is equal to 4 minutes, dt by dt is going to be minus 5. Take away 4, which is going to give me minus 9 degrees C per minute. And when t is equal to 8 minutes, dt by dt is going to be minus 5 minus 8, which gives me minus 13 degrees C per minute. Okay, so what we could note here is that these are all negative, and what happens is that the negative sign means that the temperature is actually decreasing, and that's what you expect. If you take something at 100, like take a cup of tea for example, and you let it cool, okay, the temperature goes down. Okay, this is not really represents a physical formula. It's just one that's just been made up for this particular example. Now we can look at this. Okay, so here I have a GeoGebra applet which I will put in the notes of the video. So here we have our function of time of the temperature decreasing. So this is the temperature. Okay, and this is time t in minutes, and therefore if I move it along, the first one was 1. Okay, we can see that the rate of change of temperature is minus 6 degrees per minute, and what you get that from the gradient of this tangent line here drawn at 1. At 4, we've got minus 9 degrees per minute, and then at 8, we've got minus 13 degrees C per minute. Okay, so it's the gradient of the tangent line which gives the rate of change. So this is just a practical application of finding the gradient of a curve. Right, so this is called rate of change. I hope the GeoGebra applet I will put in as a link to the notes of the video. I hope you've understood, and I thank you very much for watching.